Here are two additional examples of using linear equations for profit-cost analysis. Example 2, taken from Mathematical Ideas, page 327. Speedy Delivery provides a holiday flower delivery service. This year, the company needs to earn enough revenue to pay for $2,300 in repair costs for their delivery vans. On average, it costs the company $3 to make each delivery. Speedy charges its customers $5.50 per delivery. All right, so those costs per delivery, that might be the gas and kind of the wear and tear on the car. And then they also have this cost of $2,300. All right, a large cost paying for repairs for delivery vans that needs to be paid off. And then Speedy charges its customers $5.50, so that's not a cost to the company, that's actually income for them if you're thinking of it from the business side of things. Express the cost as a function of X, the number of deliveries made. Right, so we have a cost, we have a portion of this cost that depends on the number of deliveries made, and we know that that's $3. Right, 3 times the number of deliveries will tell you the cost for all of those various deliveries. And then we also have a fixed cost. The company needs to pay off that $2,300 that's not dependent on the number of deliveries made. So there are two components to that cost. Express the revenue as a function of X. So revenue is how much money is earned per delivery, which is $5.50. And we multiply that by the number of deliveries to find the total revenue made for all of the deliveries. When will the company break even? That is, when does revenue equal cost? So we simply need to set revenue equal to cost. So here's revenue, $550x. Set that equal to x, or equal to cost, 3x plus 2,300, and then solve for x. Alright, so subtract 3x, and we get 2.5x equals 2,300, and then dividing both sides of the equation by 2.5, we have that x equals 920. Okay, so if we wanted to graph the cost and revenue functions, again we need some axes and some sort of a scale that's appropriate. So notice this time I need an x value of 920. Alright, and then anticipating the questions that are coming up, we do want to know what is the cost and revenue at that break-even point. So let's try this out. Alright, and we'll just pick the second one. It's a little shorter. Alright, revenue at that break-even point, we would substitute in 920 for x and multiply that by 5.5 and find that the revenue at that point is $5,060. Alright, so we need sort of a large scale for our graph this time. So this time I've chosen to set my x-axis with a scale of 50 per unit and my y-axis with a scale of 500 per unit. And I'm kind of basing this on my break-even point, seeing that I need to get up to 920 on the x-axis and 5,060 on the y-axis. Alright, so let's graph these two functions. We had cost equals 3x plus 2,300. And I know my intercept is 2,300. Alright, so that's, let's see, about here. I can just kind of estimate here. And again, this graph isn't very accurate, it's just a representation. Now to use the slope to find the next point might be tricky just because my scale is so large. So instead what I'll do is just choose one other point on this line, and I know that the break-even point will work. Right, so that point was 920, 5,060. All right, so if I go over to 920 approximately and head up to 5,060, and that puts me about, let's see, about here. And that's a very rough estimate of where that point is. Okay. All right, and then I'll connect those 2 points with a line. All right. And now for my revenue equaled 550x. And again, revenue will always have a y-intercept of 0, so that gives you your first point. And then we also know that the break-even point is a point on that line as well. And then I can connect those 2 points with a line. Alright, so because of the scale I've chosen on this one is slightly better, you can see the break-even point more clearly, and you can also see that that revenue does exceed the cost when we hit that break-even point. So at the break-even point, how many items are sold? The answer is 920. And in this case, we're actually not selling items, but we are selling deliveries, right? Or making deliveries. And then the cost and the revenue at that point would be $5,060. Right? When will the company lose money? If they make less than 920 deliveries. Right? And then the minimum number of items, or in this case deliveries, that needs to be made to make a profit would be 921 deliveries. Right? So they have to make more than the number of deliveries necessary to break even. All right, so bump up to the next whole number. And then we'll look at one more example. Joey sets up a lemonade stand at the end of his driveway. It costs him $5 to make a sign for his stand and 50 cents per glass of lemonade for cups, lemons, and sugar. This enterprising young man charges $2.50 per glass of lemonade, and gullible or kindly passersby willingly pay the exorbitant price. Express the cost as a function of X, the number of glasses of lemonade that Joey makes. All right, so cost equals the variable cost. And if we look back through the problem, that's 50 cents per glass of lemonade. Right, and then his fixed cost, that's his $5 to make a sign for his stand. Express the revenue as a function of X. So revenue is the amount of money he's earning, which is $250 or $2.50 per glass. Okay, and then when will he, the company, Joey, break even? When does revenue equal cost? So we'll set these two values equal to each other and solve for X. All right, so here's revenue, 250X, equal to cost, 0.50X plus 5. Okay, subtract 50X, 0.50X from both sides, and we have 2X equals 5. And then dividing both sides by 2, we have X equals 2.5. Alright, so this is a very small scale, so this time I'll choose just small numbers for my axes. Alright, and I may even just want to go by ones here. Alright, so I have cost 0.50x plus 5. And actually this is so small, maybe I should even go by something larger than ones. Alright, let's go by fours here and see how that works out. Alright, so 1, here's 2, $3, or 3 glasses of lemonade, here's 4. Alright, and we'll keep the same scale here. Or, we're going to run out, aren't we? Alright, I can see from this cost function I have a y-intercept of 5, so I need to make it at least a 5. Okay, so let's change this. We'll go by 2's here. Okay, and then hopefully that will work. Alright, so I have cost equals 0.5x plus 5, and revenue is 2.5x. Okay, so graphing my cost, I have a y-intercept of 5, and then using my slope, I would go up 50 cents, all right, up 0.5, and over 1 unit. All right, so that would be, keeping my scale in mind, that's all the way over here. Okay, and then go up 50 cents, over to 2, all right, etc., etc. And then I can plot a point or a line through those points. Okay, that looks decent. All right, and then revenue, y-intercept of 0. And then my slope tells me I should go up 2.5 and over 1. And then up 2.5 and over 1. All right, up 2.5 and over 1. And then I will connect those points in a line as well. All right, and then on this graph you can see the break-even point. Looks like it's about here, and I'm slightly off because I know from the previous slide my break-even point is when x is 2.5, which should be about here. Alright, so again, this is just a rough approximation so you can see and kind of check these equations and notice that the revenue does exceed the cost after that break-even point. Alright, so at the break-even point, how many items are sold? That would be 2.5, and then the cost and the revenue at that point. So we do need to figure this out. So let's do revenue. All right, revenue was 2.5x. So 2.5 times 2.5. And that gives us 6.25. Alright, so notice in this case we do have a decimal, so we have to think about if that's possible. So in this case he's selling glasses of lemonade, so he probably would not be able to sell 2.5 glasses. So he'd have to sell more than that to make a profit, and then any less than that he would lose money. So if he sells 2 or fewer glasses of lemonade, then he'll be losing money. And then the minimum number to make a profit would be the next whole number, which would be 3 glasses. 3 glasses of lemonade. So he's never actually selling the number of glasses necessary to break even. Alright, and that's about it for an introduction to profit and cost analysis.